Sir, your voice is not clear.
We can't hear your voice.
Hope I must be audible now.
Yeah.
Yeah, now it's okay.
Okay,
Now it's
okay,
okay.
thank you. By the last time I'm just saying, uttering the things. Okay, great. Actually, what happened right today, my laptop got crashed and every such application got vanished. So now laptop doesn't know any application. To to laptop, everything is new. So right today, even I have to install the Zoom. Even that didn't happen correctly. So I am going towards the web application of the Zoom itself, and that might be the situation that right now am I full screen available or am I in the window shield?
Full screen.
Full screen. Okay, great. Let me also go for using something. Just wait 1 second. Be on the line. Let me create one notebook such that we could use it. Microsoft Word. It's Eduwing. Okay, going great. Draw. Let me go for the background. Background seems black, and I'll be taking a yellow color. Okay, good. So let me share my screen. Do let me know whether the things are visible or no, because right today we have to learn statistics, or must I say,
Not visible. Not visible.
via doing one case study. Hope hope I remember. Yeah, I can recall that I have given you one question to solve. Had you guys
Yeah.
done that?
Yeah. We did.
Okay, sure. So right today I'll be discussing that question in detail and asking you the insights out of it. Okay, that is the fundamental objective of this class, because learning has to happen. This is the way. So how many of you have joined? Let me check. Only 11 participants till now. Okay, in the meanwhile people must be joining. Let's move ahead. Yeah, let's move ahead. So I'm sharing my screen. Do let me know why it is not coming. I think entire screen would suffice. Let me check my window, Chrome tab. No, it's not taking anything else. Okay, I'll be taking entire screen. Okay, visible
No, enter screens available.
means my entire screen is available. No, you can see my
Yeah,
screen
your entire screens.
now. Now,
Yeah.
okay. So I'm going to the full screen mode. Hope the black screen must be visible.
Yes.
Okay, thank you. So right today we will be doing our case study, case study with respect to the measure of measure of dispersion, which indirectly includes which indirectly includes all the measures of central tendencies. Central tendencies. Would you guys like to name a few measure of central tendency quick? If I ask you what would be the measure of central tendency, would you like to give me an answer about?
Median
Very good. Mean, median, and
mode.
mode. Thank you. Great. You are learning the things. There is now this measure of dispersion. Hope you know the names. There are three. What are they? Three measure of dispersion. Anybody?
Three measure medium.
No, no, no. Measure of dispersion, not central tendency.
Measure of what are you
Dis-
asking?
dispersion. See, it is written in front of you. It's written in front of you.
Measure of this measure of central
Sorry. Speak aloud.
the central
Central. See, center has to be
measure
there,
of
no? Yeah, measure of
yeah
dispersion. In the measure of dispersion, see what is the meaning of dispersion? Dispersion says how spread it is. Yes or no?
yeah
How spread
yeah
it is. So when
it
we
is.
seek for spread, we go for range. That what is the range? That what is the range means very simple thing. What is the maximum value and what is happening to it? What is the maximum value? Let
Hmm.
me. Okay, I don't know why it is not responding. Just 1 minute. Let me
Okay.
uh, let me make it downwise. Is my pen writing in front of you or it is simply hovering around?
Before it's writing, no?
Okay,
Yeah,
one
can say.
second. 1 second. My screen is not responding. My screen is not responding. I don't know why. Today this is happening with this laptop. Even I'm not able to stop the screen or do whatever. See, it is not writing the things, else I would have started maintaining writing the task and finish the class, but no, it's not responding. Can you see? I'm trying to close this, but it is not getting closed. Let me go for control alt delete. It should allow me for end task. Let me
Hmm.
check it.
Okay.
No, it is not happening. Okay, allow me to close the system and rejoin again. Okay, give me 2
Okay.
minutes. Okay,
Okay.
thank you.
Am I audible, guys, now? Sanesh, Betsy, Abdauji, am I
Yes, sir.
audible? Yeah, thank you.
Yes, sir. Audible now.
Yes, sir.
Audible.
Thank
Yeah,
you,
audible
thank you,
now.
thank you, thank you. The things got recovered. Actually, the system went into the refurbishment. So I don't know what happened. It's happening right now. I'll ensure that by the next time it shouldn't happen, but because we call it computer glitch, it's not in our hand. So great. Let me just share.
Yeah, it's normal. It's normal, sir.
Yeah. So everybody should understand such things. So right now I'm creating one thing such that we could discuss our case study. Do we want to rename new software? I think I have already created it. Okay. Eduwing. Go for it. No worries. Yes. Now I'm sharing my screen and we shall go for Eduwing 2. Hope it will be visible to you. Do let me know whether it is visible to you or no.
Yeah, that's good.
What is visible to you? Please let
Right
me
screen.
know this also. Only the screen?
Yes, sir. Yes, sir. It's visible.
Thank you. Let me draw. See how you can change it. Say, I have opened the Microsoft Word, okay? Simple Microsoft Word. In this Microsoft Word, because I have this pen tab, if you can see this pen tab, just apply with format background, go to the page color. If you can choose black because it gives a good impression to us, although I usually do not use black. And here in the drawing tool, you may go for selecting the yellow color such that it gives a good impression over the black. Yes or no? So that's the reason it is making a things about. So we can go for our case studies. Doesn't it looks good?
Yeah, it's good.
Yeah, so always try to find something new out of the thing. This is the only say request to you guys, because you might be older than me, some of you might be younger than me, and some of you must be experienced than me as well. But yes, as far as technology is concerned, I can guide you a bit. That I can surely say about. So making it Full screen, great, going great. And now I am reducing this as a talking window. So case study with respect to our, what's that thing? We call it case study with respect to our measure of dispersion. So we had seen in the measure of dispersion, we already seen that yes, central tendencies were only 3. But what about the 3 measure of dispersions we had? One was the range. Range only provides you by the minimum value and the maximum value. Mind it, minimum value and maximum value. If you go for variance shall actually range do not provide any information about distribution, or may I say data distribution. It will only say your minimum value is say -74 and maximum value is say +234, suppose. So there is only extreme values available as far as the spread is concerned. But how the spread will go on has no information about that. Range has data distribution, zero knowledge of data distribution. Zero knowledge. Will you guys LEDG, zero knowledge about data distribution. Do you agree with me in this range? Zero knowledge of data distribution.
Yes.
Whereas the variance is concerned, we call it sigma square. In this variance, we have knowledge about data distribution. So we can see data distribution here, but we do not have any physical significance of data distribution. That what do we derive out of it? Do we take any decision out of variance? Not exactly. To take a decision, to make a things physically significant, we should or we must go to standard deviation. Standard deviation. Because this gives us the physical significance. Physical significance. And I have shared you one case study which I am going to discuss today. So hope you remember our question that we had a patient data. Okay,
Yes,
how many of you have done that?
I did it.
Thank you. So start weight we had, and we also had end weight. These were the things we had.
Yeah.
Very good. So what was the extra column I'm supposed to draw?
Variance.
No, one. Okay. See, how would you calculate variance? That is the question. If you go mathematical wise, you will find the variance via say xi, means every point minus the mean divided by the total number of points, and you have to take the square of it and then do the addition, I equal to 1 to n. Yes or no?
Yes.
Yes. So say, let me write our patient. Say, how many patients were there? I believe 5.
5.
1, 2, 3, 4, 5. First patient is having the weight of 85. Then we have 92. Do let me know because data is not in front of me.
88.
88. Next.
76.
76.
95.
95. Thank you, Abhilaji. What were their end weight? Actually, they have been, means you were given that be a data scientist, be an analyst at a healthcare clinic, and that was very sensitive data. In order to say, see the progress of the patients over the last 2-week programs, the weights definitely in kgs of these 5 patients were required to be measured at the end of the program, and then we have to take the may I say output that what were the achievement after the program end. So their end weight were being calculated as, if you give me an answer, what were the end weight for the first?
78.
78. Second?
85.
85. Then
83.
83. Then
72.
Finally
90. 90.
90. Thank you. So we had seen after the 12 weeks, this is the 12 weeks after 12 weeks, their individual weight is some of the people have gained the weight. I think yes or no. No, nobody has gained the weight. All have reduced the weight. So
Reduced.
I'll go for difference of the weight, because I asked you that please create one more column in order to calculate all the mean, median, mode of the weight loss for the patient, then determining the variance and standard deviation, and finally the skewness. So difference of weights after their 12-week program came about to be. Give me an answer here. What's the
7.
thing?
7.
Okay, 7 kgs. Then
7. 7.
7 kgs. Then
5.
5 kgs. Then
4 kg.
4 kgs. Then
And last 5 kg.
5 kg. Thank you, Vilash. So these were the differences we actually calculate from our data set. This has to be kept under the hood, and we won't omit this data till last. So what was the first thing to be calculated? Say, does anybody remember? The first task was,
Mean.
see, the first task was mean also, median also, mode also, but of the weight loss of the patient. So first task was to calculate the measure of central tendency, mean, median, mode of weight loss. Mind it, the question asked of the weight loss. So what is the weight loss of the patient? See here and guide me. You have start weight, you have end weight. So what is the weight loss?
The difference.
Very good. Difference is the weight loss. Does everybody are with me? Does everybody find Abhilash answer to be correct?
Yeah.
Weight loss means difference of weight. Simple.
Difference.
Yeah. So mind it. Suppose if there anybody would have gained the weight, say suppose any harmonic imbalance happened, so that would not be considered as a weight loss. That would be considered as weight gain. Else, while including it into the weight loss, you should have done one change. What is that? Anybody? Suppose what I'm saying, suppose there is, what happened? Suppose there is one special guy, let me change the color. There was a special guy who had 90 kgs before. Now he gained the weight 98. So here 8 kgs different has come. So this is not the, okay, that is the difference of weight. But if I go with the weight loss, I should go with, okay, 7 kg, 7, 5, 4, 5, they are weight loss. But this 8 kg should be come into minus in that situation. Do all of you agree?
Minus. Yeah.
See why I'm saying so.
How it will be minus?
Yeah, how it will be. Very good, Abdauji. You should have raised this question. Thank you for this. Suppose if I would have given the first 5 as a minus, that what is the weight loss? Minus 7 kg. Okay, suppose even if I would not have written this as well, weight loss, I would have written what is the weight change. Okay, weight change. And I would have added minus 7, minus 7, minus 5, minus 5, minus 5 and plus 8. Suppose finally plus 8. So weight change is less for all these 5 participants. Now, Abdauji, please respond.
Yes, sir. Yes.
So may I say they all have lost the weight, all the 5. So minus number is there, but only there is a one. Yes, there is only a one guy who gained the weight. So plus 8 is there. Now think it otherwise. Now think it on the other side of the coin. We are taking plus sign for the weight loss. Okay, we are taking plus sign for the weight loss. So don't we take minus sign for the weight gain? Have you got it now? How plus, how minus?
Yes. I got it.
Yes, that is the thing. So if there would have been asked a weight loss, and there in the data, if you would have any person who mistakenly gained the weight, you should have given minus sign to that guy. That is my ultimate thing to explain. Let me, I think, increase the size. 1 second. Okay, I have to take it down. 1 second. This is the only thing that I have to make this work. Likewise, and this I would have started earlier. So, okay, I'm simply, let me copy this to the first page. Control A, 1 second. Control A, then Control X. And if I take it to the first page, does it works? Let's check. Control B. Control B. No, it did not work. No worries. 1 second. Okay, it is taking everything differently. Actually, such things do not take Control A. Okay, no worries. We already have this data. Now I'm making our learning mean median mode from the first page now. Whenever we would like to refer to that, we shall refer. So what would be the mean for all the weight loss? Question comes to you. Yes, Abhilashji, you have done this. Please give me the mean for weight
I
loss.
think we have
Yeah,
to add everything.
mean, I got a 5.6.
And
5.6.
total over of.
Abdauji, you are saying something?
Yeah, I mean that we have to add everything. And
Yes,
total
you have
of
to.
number of.
Yes, add and then divide by the total number of weight losses.
Yes, sir.
It means we had 7 kg loss by the first
7
patient.
plus 7
Again, plus 5
plus 5
4
plus 4 plus 5
divided
by 5.
by 5. Very good. So this will come out to be 28 by 5, and that comes out to be 5.6.
5.6.
So what is the unit of it? Unit
kg, sorry, 5.6 kg.
Sure. Yes, it would be kg.
Anyway, I didn't write it.
See, that is the thing. We get mesmerized. Oh, what the interviewer asked to us. Okay, what the teacher asked to us. So we get sometimes baffled. Ki, what should I answer? So don't be at peace. See, what are you adding? You are adding weight losses. If you are adding weight loss, they all are in kgs. If you divide by 5, it will again come in kg. So your mean weight loss come out to be 5.6 kg. Note it down. Then, if you go for the median, how did you get the median, Abhilashji and everybody else?
Yeah, n plus 1 divided by 2.
Okay, you said n plus 1 divided by 2. Why did you do this?
This the number of
say
1 second, number of 15.
See, if you do, suppose if you do this,
then okay, tell me.
suppose if you do this, you have 5 patients, 5 plus 1 6 by 2, and you will get 3 as a median. But mind it, do we have any number 3 in the weight loss?
No.
Then this approach is not correct. So see,
So
very simple. Yes. We have very simple way to find the median. Everybody, please pay attention. Whenever you have a low data, means very less number of data, you arrange them either in an ascending order or in a descending order. Simple.
Descending order.
So go for 4, 5, 5, 7, 7. Simple. Travel from the either side, you find the middle guy. So median means median means the
middle one.
Yes, the middle guy. So the middle guy is 5. No formula, nothing. Why we applied the formula there? Let me remind you. When we have even number of population size or even number of sample size, in that situation, say suppose I found, say if now we have a median 5, let me write it. So this is wrong. We have a correct median of 5 kg. suppose if we would have one more number, say 9, then 5 and 7 would have come in the middle. Then you would have done the mean of these two numbers. Means 5 plus 7 by 2 comes out to be 12 by 2 equals to 6. Okay. So always go for calculating the mean of the two number for the median when the number of sample is even in number. Okay.
Okay.
Thank you. So if this is understood, then give me the mode. What is the mode here in this population?
Mode answer should be 5 and 7 because which is the repetition? 5 repetition there, 7 repetition is there.
Okay, Abhilash Vishwanji is saying 5 and 7 are mode. How many of you agree with him? Guys, how many of you agree with him? Or there might be someone who disagree with him? You may write in your chat or you may directly answer me. Abdauji.
Why we have to take the 7? Because it's twice in the list or what?
Okay, Abdauji is quite doubtful that why to take 7. I'll answer you, Abdauji. Anybody else? I think how many people are there? Let me come to the screen. Roy Joy, Betsy, what's your opinion? Shanesh, are you here or simply joining the class? Prakash, Jobin, Sayyid Shabir. People
Yes,
are...
sir. This
Yeah, Shanesh.
yes, this mode of this data set because this appears most frequently 2 times.
Okay, great. So Sanesh and Abhilash had given the correct answer 5 and 7. And Abdauji, please listen. Whenever we have something in repetition, that we call it a mode. So here we have 5 repeating twice, and 7 is also repeated twice. So we will having 2 modes, 5 and 7. That's why we will call this data to be multimodal. Multimodal. Whenever we have 2 modes, we call such a data set or such a model to be multimodal. Okay. So always see for repetition. So we also say that number 5 means the patient who has lost 5 kgs are most popular. Or must I say number 7 kgs, those who have lost 7 kg are also most popular. So out of the popularity, 7 would be the first most popular and 5 kg loss would be the second most popular. Does it make sense?
It's both of the same.
Both of the same, but who lost the weight means who lost the higher weight? 7 kg.
7 kg. 7
So,
kg.
so 7 kg guy are the most popular, the first most popular.
Yeah,
Soon
correct.
after the people could not make it for 7 kg, we can say, okay, who are the next patients who lost the weight 5 kg? Then they will be rewarded as the Olympics game. In the Olympics games, who brings definitely higher points will be given a gold, then silver, then bronze, and then finally nothing. So that's the thing, we go for mode kind of thing. So here our understanding from this data is the people lost 7 kg as well and 5 kg as well, and it is popular. So such a program is responsible. If you join these programs, such kind of things, there is a higher probability then you can lose 7 till up to 7 kg of weight only in 12 weeks. Do you make sense? Likewise?
Yes.
Yeah, thank you. Soon after this, if I go for the next question, the second question here, what was the second question?
Standard deviation
And variance.
and variance.
Variance and standard deviation of what? Of what?
Weight loss.
Weight loss. Thank you.
Determine the variance and standard deviation of the weight loss.
Weight loss. So now we have been asked that how do you interpret such a deviation? Means now we have to do the physical significance of it. But in order to do the physical significance, we are supposed to find the standard deviation. To find the standard deviation, we are required to find the variance. This is mandatory. So if we go for variance, sigma square, so how should I move ahead? We have so many points, say 5 points, 5 patient. So we will be going for 5.6, the first starting weight. Hope you remember.
Yeah. Yeah.
No, 7. No, 5.6 is a mean. See, first,
7 minus 5.6.
yeah. First of all, let me write the formula. Abhilash, let me write the formula. Xi minus mu whole square and the summation from I equal to 1 to n and divided by n. Simple. If we have formula, we can go into, means we can go deeper. So xi minus mu is here. Xi, what is xi? See, we already know mu. We know the n. But what is xi now? Give me this answer.
X is equal to this one, weight loss number.
Yes, you are correct. Give me answer. May I say
difference of weight loss?
Very good, Roger. Very good. Abhilash, you are also correct. So yes, so 7, 7, 5, 5, 4 is actually the thing. 1, 2, 3, 4, 5. So we can write it in any order while calculating the variance. Okay, no worries. So now we will be more interested to actually do their difference. So 7 minus, what is the mean? 5.6.
5.6 all square.
So please calculate these values. 7 minus 5.6 whole square plus 5 minus 5.6 whole square. Give me the answer, Abhilash. You have done that. Everybody else, please do it. Abhilash, wait for 1 minute. Let others also do that. Plus 4 minus 5.6 whole square. 1, 2, 3, 4, 5. What should I write for the first one?
1.4 all square.
So what is the answer?
Answer should be 1.96.
1.96. Very good. 1.96 plus 1.96
plus 0.36.
0.36 every
2.56
2.56 plus
0.36.
0.36. How come twice 0.36 came?
Because our weight loss is 7 plus 5 plus 4 plus 5.
Okay, so see here, for 7, okay, for 7, this number is okay, fine. For 5.666, 36, fine. For 4, what is, okay, sorry. I have actually written here at last. Sorry, it is 2.56, correct, thank you. Actually, I thought differently. Thank you. So this is for this. Now dividing by how much? 5.
Number 5.
And what is the final answer?
Finally, I got it to 1.4.
7.2 divided by 5, 1.44. So 1.44 is actually the, okay, what is the unit for it?
This one, 1.44. This is one unit. It's not a kg.
See here, xi, see the unit of xi. See the unit of xi. It is kg.
Unit of
xi is kg.
Kg, yeah.
Kg minus, what is the unit of mean? Mean weight is also measured in kg.
Kg, yes, kg.
So kg minus kg is again kg.
Yeah, kg.
And we are doing the square of that.
Yeah.
So it comes out to be kg square.
Kg square.
Does it make sense?
Yeah, kg square.
Kg square, does it make sense? Kg square?
No.
No, means no physical explanation to that. But yes, we found mathematical spread. So here from, to actually derive the physical significance, my dear, physical significance, we are supposed to know the standard deviation, which is calculated by taking the square root of sigma square. Now you take the square root of 1.44. It comes out to be how much? 1.2 kgs. See, we are also taking the square of kg square. Sorry, under root of kg square. That's why kg is retained. So see, standard deviation came out to be 1.2 kg. Now, I have given you the interpretation of standard deviation. Hope you remember the height of the dogs we had done. So how would you be able to implement that knowledge here? Anyone? What should I do with this 1.2 kg of standard deviation? What should I understand from it?
This one, make it one horizontal line.
Okay, make a horizontal line of 1.2 kg. Okay. Now what should I do?
And we can
make-
calculate with the low standard deviation and standard.
Okay. Okay. Then let me use a different color for this. Then say suppose as far our basic understanding covers. So we have no, actually we should draw a line of a mean, not a standard deviation. So this line should be of 5.6 kg. Okay.
5.6 kg.
Yes.
Correct.
And we had
Then add-
we had weight loss of 5 kg. So I'm writing weight loss of 5 kg here. Again a 5 kg by another patient, and again a 4 kg of another patient. Okay.
Yeah.
Similarly, we have a weight loss of 7 kg. I'm marking up, and again a 7 kg marking up. So this distance is
1.2.
something which we want to take care about. So say if we go for, hope you remember, mu plus 1 standard deviation and mu minus 1 standard deviation. Do you remember this?
You,
Mu means mean.
I mean,
So mean plus 1 standard deviation. So the mean is 5.6. The standard deviation is 1.2. So
1.2.
5.6 plus 1.2 comes out to be how much? 7.8.
7.8.
And 5.6 minus 1.2 comes out to be how much? 4.4.
1.4.
4.4 kg. So see,
Of
what does the standard deviation represent? That these are 7, 7, 5, 5, 4. I think 4 I should make near. I should make 4 near. I have made it. So say 4 is here. So this is the difference. So 55477 kgs are being lost by people as a patient. And now our standard deviation is calculated 1.2 kg, which says when you go one standard deviation away from the mean, you get 7.8 kg. So it says that 7.8 kg is very normally to be lost or expected to be lost in this program. Okay. So we can say till 7.8 kg, the weight loss seems very normal. Does it make sense to you? Guys,
No, I didn't have 7.8 kg.
till 7.8 kg of the weight loss, if somebody loses the weight by 7.8 kg, it is very normal.
Normal,
This is
sir.
the meaning. Even if the person loses the weight, okay, till the lower range of 4.4 kg, weight loss is again normal. Means now what is the range of a normal weight loss? 4.4 kg to 7.8 kg. Does it
Okay.
been understood? So now I'm writing it here. Losing the weight between 4.4 kg to 7.8 kg seems to be normal. Yes or no?
Yes, normal.
Now, anybody who either lose the weight greater than 7.8 kg or lose the weight less than 4.4 kg should come under scrutiny. You should scrutinize that patient, that why this person lost so much of weight, or why this person lost just nothing, what happened to him or her. Make sense? Guys, so whenever in our case, if we go and check, is every weight normal is every weight loss is normal, or somebody should be scrutinized?
Yeah.
Is it normal? All of you, Roy Joy, Sanesh, Abdauji, what's your stake? Betsy, you are not talking today. Jobin, Kunal, Prakashji, Sayyid Shabir.
I think it's not normal.
Okay. You think it's not normal. What is not normal? Please, explain to us. What do you think do not normal?
In this case, we can apply for skewness formula.
Yeah, we are going to do that. But till now, whatever the standard deviation says, doesn't it seems normal? See, standard deviation says that I belongs to 1.2 kg. Means it is okay if a person with a mean average weight loss of 5.6 kg loses more 1.2 kg ahead. It's okay. And hence we say 7.8 kg seems normal from the mean. Mind it, everything is done from the mean. So on an average, 5.6 kg was lost in this program. If somebody loses more 1.2 kg, it's okay. Because there might be a situation, somebody is very enthusiastic about the program. Somebody has come, somebody is following the diet very religiously. Somebody is not, somebody might be preparing for marathon. So he or she is losing the weight. Are you getting the human body interpretation? So somebody might be on the mission to lose the weight. That is these are the possible reasons to figure out. Or on the other end, on the other side, what happens? There might be a situation that, okay, we had 5.6 average. Somebody might not be following the diet. Somebody might be having sweet potatoes, might be having chocolates, might be chewing chewing gums and sweets. Isn't it, Roger? Try to understand. So 5.6 kg minus 1.2 kg is also possible. That few guys, due to their food habits, they only lose 4.4 kg. It's okay. But anything above 7.8 and below 4.4 should be scrutinized. This is the thing to be learned here. Understood, Ishaya?
And shall I ask one question?
Yeah, sure.
But see, you are getting average 7.8 kg and 4.4 kg. What is the formula of skewness?
I have not started even skewness. Abhilashji, I have not even started the skewness now.
Okay.
I am discussing that you should know how to interpret the standard deviation. Like how consistent people are. This is what it is showing. If there would have been any guy having 8 kg of weight loss or 9 kg of weight loss, that guy is not consistent.
But in our summary, already is showing 7 kg and 5 kg and 4 kg. But how you are getting 7.8 kg?
Oh, see, in the summary, let me change the color for you. In the summary, we are having weight loss calculated for the patients, which were 4,
Yeah.
5, 5, 7, 7. Fine.
Yes, correct. Yeah.
These,
Correct.
these are the
I
actual,
understand that.
actual,
Okay.
actual weight loss span. And we are calculating standard deviation, which came out to be 7.8. Okay.
Okay. Yeah, okay.
Thank you.
Yeah.
Let's move ahead. Now, all of you are waiting for skewness and kurtosis. My goodness. Third question in that case study, asking for skewness. So, do let me know what is the skewness you found, Abhilashji?
Skewness actually, I'm searching from Google. Mean minus mode divided by standard deviation.
But
This is
this one.
This one I got it. That's why I have doubt.
Okay, let me write in front of you. This is xi minus mean divided by standard deviation raised to the power 3. Remember our last question. Okay, all of you, let me give you one answer from Athira as well. So I asked Athira ji that please allow people to have their notes and what is that? Recordings. It is already uploaded on YouTube, man. I have checked myself. All my notes and all my presentations and your classes are uploaded on YouTube. Please check Eduwing by Deepak Kumar. You will be finding it. Okay, all of you.
Okay.
You come last time you complained. This is the thing I found. So I checked personally. It is available. So now the skewness formula comes with n upon n minus 1 into n minus 2. Simple. And when you do this, you find the answer of s equals to 0.0003. It's almost equals to 0. So if skewness is 0, what is the interpretation?
No changes.
No. Try to get
No.
the basic answer. What does the skewness represent? Asymmetry. Skewness represent asymmetry. How asymmetrical things are. Your asymmetry is having 0 value, man. 0, no asymmetry. It means your data is symmetric. Yes or no?
Yes.
If your data is symmetric, then can we say that it follows normal distribution curve about the mean? So most of the data are normally distributed. So we have good standard deviation as well. So therefrom you can check that here the standard deviation being a say 4 kg change here, then we have 5 kg change here, and we have 7 kg change here. Yes or no?
Yeah.
So try to see likewise. Then only you would be able to draw the things, interpret the thing, digest the thing, and feel happy. Say if food do not get digested, we never feel happy. Always the gas problem comes. So don't be in the impression of gastric thing. Similarly, if you go and calculate your kurtosis, this kurtosis comes out to be from the fundamental formula. I'm not writing the formula. I have this number. So it comes out to be minus 1.3, man. Minus 1.3. And whenever a kurtosis comes negative, we call it as a plateaukurtic. We call it as platykurtic. And whenever a platykurtic things come, it means plateau is coming. From the platykurtic things, it comes plateau. Plateau means flatness. So see here the flatness in the curve. This curve, if mind it, even this curve is actually following the symmetry and at the same time kurtosis. But
Kurtosis.
suppose if this curve would have been likewise like this, so this curve would be leptokurtic, yes or no? Leptokurtic, because it's showing the less standard deviation or less variance. So this was the learning to all of us, that yes, how to ensure the standard deviation whatever has come from the pictorial representation as well, because pictorial representation and the numerical computation should not vary, they should indicate the same thing. That's why we go for mathematical kind of things, man, here. So what is the quantitative feedback from this analysis? Quantitative feedback. Quantitative. If you would have joined this 12 weeks program of weight loss, what you would have felt, say your mean weight loss mean is found out to be 5.6 kg. Now write everything. Your median is come out to be 5 kg. So whenever the mean and median are in the same range, whenever the mean and median are around same, we say this indicate that the program means the weight loss program is generally effective. I'm not saying especially effective. I am saying generally effective. It is generally effective for the majority of patients. Yes or no? See, your mean represents the majority, your median represents the majority. And they both are near to each other. They are not deviated so much. They are very near. So if such a analysis comes into picture, we usually say program is generally effective, not especially, generally effective. So as many people joined, most of the people were found with a good result. This is the meaning of it. And the positive weight loss. Second thing is we found the positive weight loss. Positive weight loss. The positive weight loss indicated that it shows that all patients experienced the weight loss. Is there anyone who experienced weight gain? Nobody? No one. Everybody lost the weight.
Everybody lost. Yeah, correct.
So if you are, say, suppose if I ask you to offer, okay, I am running a program and I am making you sure that within the 12 weeks, you will be losing 5 to 7 kg of weight. And this is the cost of my program. And if you do such an analysis of the program, and if you are very much serious about losing the weight, won't you join it? Yes or no? This is the simple thing.
Simple, yeah, correct.
So, and hence we had also found that we had the standard deviation of 1.2. It means how consistent the weight loss were there. In the result, across the patients, the weight loss is relatively high. 5 kg, 7 kg, 5.2 kg. What's that? It's a good weight loss. So this is what we had understood from this. Hope I make sense from this case study to you, how to interpret standard deviation, how to interpret the quantitative feedback. If mean and median are same, it means it is affecting the majority of the people. But if they are different, it is not affecting the majority of the people. So this is the way to interpret statistics. And believe me or not, it's going to help you in life if you apply it seriously. Okay. So let me stop sharing this. Any question, guys? Please come to the dashboard, your own favorite dashboard. Hey, Shanesh, great. So I hope, see, right now I'll be starting after this session. I'll be starting What do you say? Should I start probability? It seems tough. It seems tough. I understand. Probability seems tough. But the way you shall be taught about the probability would be mesmerizing. That how to actually, what do we understand from probability? That we likely to say, okay, how to go for calculation, how to actually apply dependent event, independent event, mutually exclusive event. It creates havoc in the mind sometimes. But if you simply see the probability with the event, with the logic, with the things happening around us. Say if I ask you, what do you say? Can rain and sunshine happen all together? What do you say? No, rain and sunshine usually do not happen all together. So these two are mutually exclusive event. Simple. They happens exclusively. They do not happen all together. So this is the reason, because if you do not learn probability, there is a very less chance you be successful in life. If you apply, see here in India, a Reliance owner, who is that guy? Reliance owner, Mukesh Ambani. Mukesh Ambani applied probability and he is having worth billion crores of company only on the probability. Mind it, probability makes a lot of sense. If you will take if you will apply your guts to learn it, you might make a good decision basis that. Say if you are going for opening SIP, systematic investment plan in the market, share market, and you are going or you are into the journey of wealth creation, probability is going to help you. That you will calculate chances. Actually, it represents chances, likelihood. What are the likelihood that you pass? What are the likelihood you fail? Simple. Okay, even you do this while crossing the road. You measure the what should I call? You measure the I won't say you measure. You estimate at what speed the vehicle is coming. You estimate how much far it is from you, and then you either decide to run or you decide either to do a moonwalk on the road. So this is the statistics, man. So I will try to continue my journey with the statistics application, with the hypothesis learning, and soon after, before the hypothesis, we will go for probability. Does it suffice? Yes or no?
Okay.
Okay, Sanish, you are on mute.
Okay, sir.
Okay, you seems good now. Be blessed likewise. Okay guys, if anybody else want to come on the screen to have your picture, then you are most welcome. If you are there, thank you, Abdauji, you are here. Going for thumbs up. Prakashji, Roy Joy, Kunal, oh my god, beautiful faces. Print screen, thank you. Keep shining like this. Be happy, be workable, and learn every day, please. I don't have opportunity to give you every day a class, but definitely if I would have, I won't be back. But do learn every day, and all your classes, all your recordings are there on YouTube. Check it from Eduwing by Deepak Kumar or Eduwing by any facilitator name or a faculty name. You will find it. I found it, yeah. You will also find it.
Okay.
Okay. Chalo. All the best. Take care. Good night. Bye-bye.
Okay, sir. Thank you, sir.
Apa? Jangan sering. Hingga mari